Hey guys, and welcome to a new video of this computer vision and MediaPipe tutorial. In this video here, we're going to do holistic detection with the MediaPipe module that we've been using in the previous videos here as well. So in this video here, we're going to do the holistic detection where we're going to track around like the face mesh together with like a pose estimation of the body. So we're going to track different kind of like elbows, shoulders, knees and stuff like that. So the different kind of features that we have when we're tracking like this holistic. But first of all, remember to join the Discord server. I'll link to it down in the description here, and you can come join and chat with us about like computer vision, deep learning, artificial intelligence, and so on. You can now also become a member of the channel here if you want to support the channel even more than you're currently doing with a small monthly fee, and everything will go to create more and better quality content here on the channel. So thank you guys. So we're now jumping into the code here, and I'm going to show you how we can set up this MediaPipe module here, and how we can set up the different kind of methods, and how we can draw the actual like holistic that we're detecting in the image frame on the image itself. And then at the end of the video here, I'm going to run the program and show you how we can actually like track the holistic round in the image frame. But first of all, we're going to set up the different kind of like both the drawing utilities and the holistic detector as we did in the previous videos. So make sure if you want to like know how we can set up a face detector, face meshes, or like how we can do hand detection where we're tracking the hands around in the image frame, the setup is very similar for those as well with the MediaPipe module here. So it's very easy to set up. So if you're interested in those different kind of detectors, make sure to check the previous videos out. All we have to do is just to like set up the drawing utilities, set up the detector that we want to use, and then we can just have a for loop that is running through all of these detections in the image. We just pass our image through this process function in MediaPipe, and then it will do everything for us, and we can just draw the actual detection on our image frame at the end. So all the videos are very similar, and you can use them all for the different kind of detectors that we have. So first of all, here we know that we need to import OpenCV because we're going to use OpenCV to actually like load in the image from the webcam. Then we're going to do some conversions between PGR and RGB. Then we're going to process the image, and then we're going to actually like show our image in OpenCV as well, where we're going to draw the actual detection on that image. So that's why we're importing OpenCV here as well. We're going to import the MediaPipe module that we're going to use as MP here. So when we're going to use this module here, we're just going to reference it as MP, and then we can use the actual like the different kind of built-in methods in the MediaPipe module here. We're also going to import time because we're going to track like how long it actually like takes to run this algorithm, so we can get the number of FPS for this machine learning solution here. But as in previous videos, first of all, we need to set up these different kind of like objects here for the drawing utilities and also for the holistic detector in this example here. So first of all, here we're going to have this MP underscore holistics, and we're going to set that equal to the MP here. So we're going to use the MediaPipe module here. So we have MP dot solutions. So all of the different kind of solutions and drawing utilities is built into this class here in MediaPipe, where we have this MP dot solutions. And then we can actually just have this dot operator here, and we can just type in holistic here at the end here with a lowercase h in this case here. So now we have actually like set up the detector that we can then use later on down here with this width here, where we can set up some different kind of configurations for the minimum detection confidence and the minimum tracking confidence. But first of all, we just need to set up this object up here at the top. So now we actually like have the detector for our holistic detection. So now we need a class here, or like we need an object to actually like draw from the drawing utility, so we're actually like able to draw the holistic detections that we're going to do later on. So we're going to have this MP here underscore drawing as we had in the previous videos as well, and we're going to set that equal to MP dot solutions here again. And then in the solutions here, we have this drawing utilities that we're going to use. So we have this dot drawing underscore utils. So this is the drawing utilities that we're going to use to actually like draw the holistic detection in the image frame. So now we have everything set up here to actually like be able to run this holistic detector here later on in the code. Then we need to open up the video capture here. So I'm just going to use the webcam that I've connected to my computer. So we're going to use that here as our capture here that we can then read in images from. Then we can go down here and use the actual like holistic detector that we just created up here. So the object that we created up here. So we have this with MP underscore holistic dot holistic. So we can set up some different kind of configuration for our holistic detector in this example here. So we have our minimum detection confidence, we set that equal to 0.5. So this is just a threshold value. So if the confidence is over 0.5, then we're actually like using that holistic as a detection. So we're trying to reduce false positives in the detections with this confidence score here. And also the tracking confidence, we can set that to remove some false positives and stuff like that. So we can just play around with this with this threshold here and just do some trial and error to fit it so it suits your application or like project the most. And then we're going to open up this holistic detector here with these different kind of configurations as holistic. So later on in the code, when we're going to run the actual like process method, then we can just use this holistic here dot the process method that is built into MediaPipe module. So now we're going to go down here and just have this while loop here that is running like while our webcam is open here. So the cap dot is open. So as long as our webcam is open, we're just running this while loop here over and over again. Then first of all, we need to read in an image from our webcam, and we do that by this cap here that read, and then it will store the image that we read in from the webcam in this image variable. And we'll also have a Boolean variable here, which is the success if we actually like could load in or like read an image from our webcam successfully. Then we're going to start a timer here so we can actually like time how long it takes to run this holistic detector here in the MediaPipe with a CPU. So in this video here and in this project here, I'm running on just a standard CPU. So the MediaPipe module is very well optimized for common hardware. We can even run them on embedded system, Raspberry Pi and stuff like that. But in this video here, I'm just only using the CPU, and I'm just having like a common CPU where we get like a really high number of frames per second, even though we are on CPU. So first of all, here we need to convert our image from PGR to RGB. So because the functions or like the methods built into MediaPipe, they're actually like operating with RGB images. But when we load our image into OpenCV, they actually like load in as PGR. So we need to do that conversion before we're actually like going down here and processing the image and detecting the holistics in the image frame. First of all, here we need to improve the performance. So we set this flag here, writable here equal to false. So we cannot write to the image anymore because we set it equal to false here. And that means that we're passing our image as a reference instead. So here down here, we can now process the actual image. So we just have this holistic.process, and then we pass in the image that we want to process and detect the holistics in. Then we're going to store all the results here in this results variable here. So this result variable here, we contain all the different kind of like landmarks for both the face mesh, the post estimation, or like the holistic estimations for like different kind of features with the elbows, shoulders and stuff like that. And we're also going to have hand detection here in the holistic detection. So all of these different kind of landmarks and detectors or like detections is going to be stored here in the results. Then we can actually like set the image here equal to like to writable again. So we're actually like able to draw our detections on our image. So we need to set it equal to true here after we've processed our image. Then after that, we're going to convert our image back into PGR so we can actually like display what is going on in our image. And we can also draw the detections in OpenCV because we need that in PGR instead of RGB. So that's why we're doing this conversion here as well. So now we can go down here and actually like just first of all, we can just go in and here and print the results. So we can just print here results dot if we want to, for example, get the pose landmarks. So we're both going to get some landmarks for the faces. So we're going to do some face mesh detection. We're going to get some landmarks for the left hand. We're going to get some landmarks for the right hand. And the last thing that we're going to do or like get in this result variable here is like the landmarks for the pose. So the different kind of like features like the hands, elbows, knees, shoulders and stuff like that. So this here, we're just going to print out the results for our post landmarks. So we can just have this post underscore landmarks here. So we'll get all the landmarks for the different kind of features that I just talked about that we have in this post here. So if I run the program here, we're actually going to open up the image for like the webcam here. We're going to do all of this processing technique, convert back and forth between RGB and PGR. And then we can see down here, like right now, we're not displaying anything here on our image frame because we're not using the drawing utility yet. But we can see here, like when I'm moving around here in the image frame, if I just scroll down here to the bottom, we can see that the landmarks here is changing all the time here. And in this case, we're actually like having the post landmarks that we're writing out here to the output or to our terminal. And we can also see the number of FPS we get by running this algorithm here. So we can see that we get these different kind of landmarks here. They're actually like moving a bit around because I'm moving around here in the image frame. And we can see that like the more I move, the more these different kind of like coordinates here for the landmarks are moving as well. And as we can see, these landmarks here is scaled as we already went over in the previous videos as well. So if you wanted to do something customized or like something for your application, you'll need to get the width and the height of your image frame and then rescale those coordinates here to your specific image dimensions. So if we just terminate this program here by hitting escape here, we'll now terminate the program and we can go down here and actually like use the drawing utilities to draw all of these detections that we're doing in the holistic detection. So if we go down here and use the MP underscore drawing utilities, then we can actually like use a built-in method here that is called draw landmarks. So we're just going to draw the landmarks here for all of the different kind of detections that we have. So now we need to pass in the image or like the image that we want to actually like draw the detections or like draw the landmarks on. Then we need to specify the landmarks that we want to actually like draw on this image here with this drawing utilities. So in the first example here, we just want the results here dot the face landmarks. So we want to draw the face landmarks on our image frame here when we're actually like going to display and run our program later here here on. So we have the results here, the face landmarks. So all the face landmarks is, again, as I said, it is stored in this results variable here. So now we actually like get the face landmarks here, and we also need to specify the connection between the different kind of landmarks that we're detecting. So again, we just have this MP underscore holistic, and then we need to specify the face connections here. So we're just going to have this face underscore connections. So now we actually like both have the image that we want to draw the detection on, we have the landmarks that we want to draw, and then we're going to specify here how we actually like want to connect the different kind of landmarks that were specified here on the image. So now we can actually like just copy paste this here, and we can do the same thing for both the left hand, the right hand, and also for our post landmarks of our body. So if we just go down here, copy paste, we need to specify here instead of the face landmarks, we're going to specify the left hand landmarks here, and over here to the right we just need to specify that we're going to use the hand connections instead of the face connections, and then we can just copy paste this here again and do the same thing for the right hand. So I'll just go down here, copy paste it, instead of the left hand results here we're going to have the right hand, and the hand connections is still fine over here to the right as the last parameter. And then we need to draw the last thing here, which is the actual like pose of the body. So we have the different kind of like pose landmarks here. So the landmarks that we want to draw on our image frame is this pose underscore landmarks as we just printed out up here to our terminal. So right now I'm just going to comment this out here so we don't print out all of these things to our terminal while our program is running. So the last thing we need to specify here as the third parameter for connection is the actual like pose connection. So this is just a different kind of like things that we need to specify for how it is going to connect the different kind of landmarks that we are tracking in the image frame. So now we actually like have everything set up here to both be able to read in our image, convert it back and forth, process our image, get the actual like holistic detections, and then with these 4 lines of code here, we're going to draw all the landmarks on our image that we have specified here. Then we go down here, enter time, so how long it took to actually like both process the image and also display what we have detected in our image frame. We're going to specify the number of FPS here, which is just 1 over the total time. We're going to print out the FPS, and we're going to put the FPS in the top left corner of our image frame as well. We're going to show the image here where we have drawn all the different kind of detections, and then at the end here we just have this wait key where we're waiting for us to hit escape. And when we hit escape, we will actually like terminate our program. First of all, we will go out of the while loop, and then we're actually like going to release our webcam here and terminate the program at the end. So now we actually like have everything to be able to run our program here now. So if we run the program here now, we can see that we will just first of all we'll create this TensorFlow here. We get the number of FPS out here, and we also display it up here on the top. So if I just take this down here, and we can see here that we're actually like detecting my shoulders here, we're detecting the face mesh as we did in the previous videos. So this is just a combination of all the different kind of detectors that we had from the previous videos. So we can see we have my shoulders, we have my hands here, we have the face mesh with some different kind of features. We can see that my mouth here is tracked, and my eyes and nose here, it also has some different kind of features. And we can see that the further I move back, we can see now that I also get like my elbows, the shoulders, and all of these different kind of features and key points in the hands is actually like connected together, because this was the third parameter that we specified up in the drawing functions. So we can see that we get around like 20 to 30 FPS when we're just running on a standard and common CPU. We could both use the GPU and a better CPU, but this is really nice and really good FPS actually, to be able to run all of these different kind of detectors. So we both have face mesh, hand detection, post detections and stuff like that. So now I'll just try to move a bit back further, and we can see the different kind of like post detections that we have as well. So yeah, that's pretty much it for this video here, guys. We've been over like how we can set up this holistic detection here, combine the different kind of stuff that we went over in the previous videos. So we both did a video individual for hand detections, face mesh detections, and like face detections in general. And in this video here, we're combining all of the different kind of things to do holistic detections. And we can see that it works really good when we're using this well-optimized machine learning solutions here from MediaPipe. So thank you guys for watching this video here, and remember to hit the subscribe button and bell notification under the video here, and also like this video here if you like the content and you want more in the future, because it just really helps me and the YouTube channel out in a massive way. So thank you guys. I'm currently also doing a deep learning tutorial where we're going over the basic stuff about neural networks, deep learning, and so on, where we're creating our own neural network from scratch, talking about like the basic theory behind it, and then we're actually like training our neural networks, doing predictions on data that it hasn't seen before, and a lot of different kind of cool stuff. We're going to combine that tutorial with computer vision and see how computer vision and deep learning works together, as we can actually like see here with these machine learning solutions here from MediaPipe, which is just a combination of computer vision and deep learning. So if you're interested in that tutorial, I'll link to it up here, or else I'll just see you in the next video, guys. Bye for now.